Now at this point the curriculum says, yeah, I agree with you. The X, or using the tiles, is a dumb way as well. What they actually tell you to do is they're talking about distributing this X over here. So I have X times X, which is X squared, and I've got the X times negative 2. That's called, the step is called distribution. Then I'm just multiplying this out, so this is X squared, this is negative 2X, and then I've got X squared minus 2X. Over here, we're actually going about this kind of in a special way. We're saying the way you can get this answer, which is x minus 2 times x plus 3, is you multiply the first times the first, then the outers times the outers, the inners times the inners, and the last times the last. The first times the first, what that means is the first part of this thing times the first part of that thing. So that would be x squared, or x times x. The outers would be x times 3, because it's the things on the outside. The inners would be the two guys on the inside, and remember to keep that negative with the 2, so I've got negative 2 times x. And the last would be the last part of this binomial and the last part of that binomial, so that would be negative 2 times 3. This is a special, or well, let me finish doing this. This would be x squared, this would be 3x, this would be negative 2x, and this would be negative 6. If I combine the like terms, that would be x squared, 1x, minus 6. So my answer is x squared plus x minus 6. This is a special thing that we do, and we call it FOIL. When you're multiplying two binomials together, see this x minus 2 and this x plus 3? This is a, we use this thing called a FOIL. I think it's called, what is it, an anagram or something like that. It basically stands for first, outer, inner, last. When you multiply these two binomials together, you want to multiply the first times the first, the outers times the outers, the inners times the inners, and the last times the last. I kind of think of it as, imagine you have a college dorm, and the college dorm usually has 4 people in it. Now, on the first day, you have C and D inside of the dorm already, okay? Now, A and B, they're good friends, and they want to, they knock on the door of the college dorm, and they want to get inside, and they want to meet their roommates. Now, you have to make sure that A meets C, and also A needs to meet D, right? So A times C plus A times D. You also should make sure that B meets everyone inside of the dorm already, because A already knows B and C already knows D. They're already inside of, I mean, these guys are hanging out together and these guys are hanging out together, but B needs to make sure he meets everybody as well. So we've got B times C, and also B needs to meet D, so it's B times D. This is just ensuring that I'm making sure that everyone meets everyone. I'm distributing everything here. Well, I know that you're going to be confused because it's like a whole bunch of A, B, C's, and D's. But basically what I'm saying here is A and C, that's the first, right? That's the first guy from this binomial times the first guy from that binomial. The outers are the guys on the outside. The inners is B and C, that would be here. And the last would be B and D. That would be those guys at the end. So one way we can multiply out these binomials without having to really break much of a sweat is we use FOIL. We first, outer, inner, last them. Let me do it to this one right here. First times the first is x squared. The outers, that would be x and negative 1. The inners, that would be negative 4 and x. And the last would be negative 4 and negative 1. So if I simplify using multiplication, I've got x squared, negative x, negative 4x, and positive 4. I'm basically just multiplying everything out like that. Then I combine the like terms. The like terms in this case is the negative x and the negative 4x. What is negative 1x plus negative 4x? That's negative 5x. And the guys on the outside, they stay the same. So my answer is x squared minus 5x plus 4. That would be foiling that thing. Without having to use those dumb tiles, I'm done.